Good day everyone. So today we're going to discuss one of the most commonly used statistical treatment in educational research. So this is the Pearson product moment correlation coefficient, or most commonly used term, or most commonly known as Pearson R. Pearson R, Pearson product moment correlation coefficient, is used in determining the strength of relationship of two variables. So what is this Pearson product moment correlation? Or let's just use the term Pearson. So Pearson R was developed by Pearson, which is named from his surname. So Pearson developed the Pearson R, but it was first introduced by August Bravais and Francis Dalton. Now, so what does this test do? So, as I said before, earlier, this measures the strength of a linear association between two variables. So, with this Pearson R, we can determine if one variable affects the other in a linear manner. So here, Pearson product moment correlation attempts to draw the line of best fit through the data of two variables, and the Pearson correlation coefficient R indicates how far away all these data points are to this line of best fit. So the Pearson correlation coefficient R can take a range of values from +1 to -1. So you cannot have a value that is exceeding to +1 or below -1. You can have a +2, which others says that if you have a +2, then you have a very strong linear association, but that is not true. So a value of 0 indicates that there is no association between the two variables. A value greater than 0 indicates a positive association. That is, as the value of one variable increases, the other value will also increase. A value less than 0 indicates the negative association. So that would be, if a value of 1 increases, the other would decrease. So the strength of association, the stronger the association of the two variables, the closer the Pearson correlation coefficient R will be either +1 or -1, depending if it's a positive correlation or a negative correlation. Then, achieving a value of +1 or -1 means that all your data points are included in the line of best fit. There are no data points that is shown any variation away from this line. So the closer the value of R to 0, the greater the variation around the line of best fit. So how does this line of best fit looks like? So this one is an example of our set of points. So this is the R is 0.7. So you can see that the values or the data points are closer to each other. Unlike this, R is equals to 0.3, which are the data points are more scattered from the line of best fit, and then this one, R is equals to 0. Most likely, all the data are scattered on the plot. So this is your line of best fit. So you also have -0.7, which your line of best fit would be a negative slope, and then R equals 0.3, -0.3, and then R is equals to 0. So when shall we use the Pearson R in testing for in our statistical treatment, in our research? So the variables should be, we have a variable that is measured in either interval or ratio scale. So the variables can be measured in entirely different units. So one variable could be in height, so that could be meters, and the other variable could be in kilograms. So there's no restriction whether you should use the same unit of measure. So the variables here does not take into consideration whether a variable has been classified as independent or independent variable. So this is one of the weaknesses of the Pearson R test. So you would not it doesn't care if your variable, say for example, in this one. So in our examples, we have BMI and academic performance of the students, for example. So it doesn't care if the BMI affects the academic performance or the academic performance affects the BMI. It can go vice versa. So that is one of its weaknesses, that it doesn't really determine causation. So it just determines if they have correlation. Okay? So these are the examples that we, for the variables that we can use in Pearson R's. BMI and academic performance, study time and test scores, and then ICT literacy level and academic performance of the students, and English literacy level and performance in mathematics. So that would be all for its relationship, not for difference. So how to get the value of R? So there are a lot of formula in getting the value of our R. So this one I find the most the easiest to deal with and the simplest one. So that is R is equals to n times the summation of xy minus summation of x times summation of y all over the square root of quantity n times the summation of x squared minus summation of x quantity squared close quantity n times the summation of y squared minus summation of y quantity squared close quantity. Where n, your n here would be the number of pairs of scores. So how many are your data sets? So we have x summation of x and y. You are to multiply x and y, and then you have summation of x, summation of y, x squared, and then summation of y squared. So for example, we have this data. So the person, we have 15 person in total, and then we have test scores and attitude towards testing. So this is what is being tested. If the test scores has a relationship on the attitude towards the testing of the test takers. So we just need to add the column xy. So you are to multiply this 17 and 93 would be equal to 1,581, and then 13 times 73 would be 949, and so on. We have the x squared column, wherein you will square all the data on your test score or your x, and then you have the y squared. You are to square all the attitude towards testing here, which is your y, and get its sum, your total. So doing the formulas, you have 15 times 18,273. This is your x times y. As you can see here, this is 18,273. And then times summation of x and summation of y. That would be 232 and 1,168 divided by the square root of 15 times 1,640 minus 232 squared times 15 times 100, 92,474 minus 1,168 squared. Wherein, and then, at the end, you will get the R is the value of 0.740156153, or rounding off, it would be 0.7401, 7401. This value is between a negative 1 and positive 1, which is this indicates a positive correlation because the value that you get is positive. So now, the computed R is equals to this value, as we have mentioned earlier, means there is a positive correlation between the test scores and the attitude towards testing. So it says that if you have a higher attitude, a higher score in attitude towards testing, most probably your scores in test would be higher as well. But if you have a negative or low attitude towards testing, you dislike testing, then most probably your test scores would also fall. So, but the question now is the correlation that we got, this positive 0.7401, is significant. So what is this significance? So test for significance which is used for hypothesis testing. So for example, that is your research if there is a relationship. And then your hypothesis would be there is no significant relationship between the test scores and the attitude towards testing. This is your null hypothesis. And then your age of 1, there is your alternate hypothesis. There is a significant relationship between test scores and attitude towards testing. So how do we determine if that is significant or not? So we are going to use this tables. This is called the critical value table, which is used in a lot of statistical treatment. So particularly Pearson R, and then we have the other treatment, p-value SLS. So here we are just going to get its degree of freedom. So df is equals to n minus 2. So this is your degree of freedom here, and then match it with the level of significance. For this one, this is a one-tailed test. So that would be at 0.05 for the standard testing. So let us review how many test scores do we have. So we have 15 test scores, and then so 15 minus 2, the degree of freedom would be 13. So the 13, and then at 0.05 level of significance, so 5% significance, the critical value would be 0.441. So the computed R is 0.74, and then the critical value is 0.484. So how do we determine if we are to accept or reject our hypothesis? So we just need to see if our computed R is higher, the absolute value of our computed R is higher than our critical value. Since 0.74 is higher than 0.44, then our decision is to accept our hypothesis, so our alternate hypothesis. So that is how do we use the Pearson R or Pearson product moment correlation. Product moment correlation coefficient in hypothesis testing in our research. That's all. Thank you.